Hi everyone, my name is Merari Mejia Robles, and today I will be discussing electron beam machining. Electron beam machining, also known as EBM, is a thermal machining process in which high-velocity electrons concentrated into a narrow beam are used for instantly heating, melting, or vaporizing the material. This process is used in many applications, including drilling, cutting, annealing, and welding. This is a schematic of the equipment, but the main components are the electron beam gun, which generates the electron beam, the electromagnetic coil to focus the beam, the deflection coil to scan the beam, the XY table to fix your workpiece in the chamber, and the vacuum system/operating chamber. The way EBM works is by having a high voltage loaded into the anode that leads electrons to achieve a velocity as high as 200,000 kilometers per second. This kinetic energy from the electrons is then converted into heat in your workpiece. Focus and deflection of the beam are controlled using electromagnetic focus lenses and deflection lenses. Power density is controlled by the acceleration voltage. Electron beam machining can be used on metallic or non-metallic workpieces. It is used for drilling, cutting, welding, and surface finishing, depending on settings. These settings include power density, beam spot size, the acceleration voltage, and beam current. So for example, if you're looking to pattern electronic circuits, you're going to use a low power density with a low beam current and a small spot size. However, if you're looking to weld, melt, or evaporate a metal, you're going to use a high power density with a high current and a high voltage. EBM also presents many advantages, including the extremely small spot size in order of microns. This allows for further precise micromachining. The focal depth is also longer than that of laser beam machining. High voltage at the anode generates high velocities and thus high power densities, creating high temperature heating at the localized area instantly. Heat generated by the high accelerating voltage easily creates keyholes and allows for the removal of material, allowing for deep penetration. We're also able to control the high-speed beam, enabling us to fabricate very complex shape patterns at high speeds and high accuracies. However, EBM does have some disadvantages, with the main one being the requirement of a vacuum chamber. This limits the capacity and size of your workpiece and increases the difficulty of your setup. This process has high costs for equipment and operating due to the necessity of having high-skilled operators and frequent maintenance. Lastly, it has a low material removal rate. Here are my references. Thank you for listening to my presentation.